and welcome to the next video in our series of presentations about Rhapsody for systems engineering and for software development. My name is Jeff Cohen with 321 Gang. Today's video is on modeling use cases. This is the fifth in our series of videos. If you haven't seen the previous ones, that's fine. You can go back and watch them at another time. This video is all self-contained, so you can just watch this and learn how to use use cases, and then go back and look at the others later. In the previous videos, we talked about requirements, and we focused mostly on text-based requirements because text-based requirements are most common in both SysML and UML. But there are also a lot of other types of requirements. One of the more common is user stories or enabler stories. These are a description of what's going to happen from the view of the user or from an external that's not a person but is causing the system to do some reaction. But the point is, it's a story that tells what the system is going to do from the point of view of something outside. Epics are very common in agile techniques or in safe techniques. An epic includes the hypothesis of what we expect the system to do and some outcome statements to say how we expect the system to behave, how we judge performance. It also includes a lean business case to justify why we're doing what we're doing. Capabilities and features tend to be what most people think of when they think of use cases. Frequently, people just use those terms interchangeably. But a capability or feature of the system is something the system does. It can be just a short sentence, but it can also include a lot more detail. And in use cases, we do show all of that detail. Non-functional requirements are really important to the system because it puts the limits. These are things that are generally not testable or really, really hard to test. These include things like performance requirements or service level requirements and other constraints. Now, all of this is well and good, but it leaves a lot open for interpretation. And for safety critical systems or highly regulated industries, that interpretation is the risk. The goal in tightening up the requirements is to make sure that people on the other side, when they either go to implement or use the system, use it the way it's intended or develop it the way that it's intended. That's where use cases come in. So SysML and UML both describe requirements as use cases. I'll say this a couple of times in this presentation. A requirement is a use case, or a use case is a requirement. Most people, when they first see requirement or use cases, will see a use case diagram that looks something like this. The use case diagram is a good visual. It shows the use cases themselves. It shows the boundary of the system. That is, everything inside here is something that we need to build, something we get paid for. Everything on the outside is things that we don't get paid for, or somebody else gets paid for. Therefore, we shouldn't spend a lot of time modeling it. Outside, we have the actors, these stick figures. Now, traditionally, actors are represented as stick figures, which makes some people think that, well, this just means it's a person. Well, it's not. An actor can be a person, but it can just as easily and just as commonly be a piece of hardware or another system or an API or something that's outside. Now, up until a few years ago, I didn't use use case diagrams very much. I started doing so now because I found the value. See, a colleague of mine taught that you need to think of a use case as a chapter heading in the book. And the use case diagram is just like the table of contents. So it helps you understand what the system is going to do ahead of time and where things will be found in the model. So let's take a look at the pieces of a use case and everything that goes around it. We'll start with the use case itself. The first thing to know is that use cases are requirements. Use cases specify what the system is going to do to meet the other requirements. Frequently, what we'll see is use cases span more than one textual requirement. You will see the trace with this satisfies relationship to indicate that the use case is going to implement everything that's in those requirements. Now, let's take a step back so we can take 2 steps forward. If this was a competitive project where everybody was getting the same requirements, each team would probably come up with a slightly different solution. What the use case does is show our implementation of those requirements, our solution to the problem the requirements are trying to solve. In UML, use cases also provide some of the design. Now, you can't see it at this level, but underneath the use case, the refinement of the use case that we're going to discuss in the next couple of videos, that gives the detail. And that detail for systems engineers is more of a specification. For software engineers, it can actually be the interfaces, the operations that are going to call, the methods that are being called, and the response values that come back with it. When we're refining use cases, we're going to typically use things like activity diagrams, sequence diagrams, and state charts. So why are we even using use cases? Why aren't the text-based requirements or the other forms of requirements good enough? Well, there's a couple reasons for that. The first is because they're just the requirements, and it's what somebody was able to think of before they started doing a more detailed specification, before they started allocating functionality around within the system, before even defining what our implementation of that system is going to look like. So use cases show the capabilities. They also show the scope of the system, and the refinement give that more detailed understanding. Again, because we're going graphically, it's easier to get a big picture view as opposed to just looking at a bunch of text requirements out of context. That satisfies relationship brings everything into context. While we're doing the refinements, while we're allocating the requirements and tracing the requirements, we'll often find missing requirements or requirements that need more detail, derived requirements, or things that are just inconsistent between one part of the system and another. And maybe that may be okay if it's implemented over here as opposed to over there, but the context is very important. Use cases also provide a way to help communicate. A use case gives a bundle of requirements so the downstream receiver of the information can get it. That downstream could be another subsystem, or it could be the software development team, or even a firmware or electrical development team, a board development team, where we're giving those detailed requirements down to them. Use case is also very valuable for helping validate a system and to give to the test folks. It gives them a view to surround their test cases, and again, it gives them the context. And it helps provide a linking point to link requirements, system functionality, subsystem functionality, software functionality, and the test, all based on one use case. Another view of the use case is that they help define usage. A use case will give step-by-step what happens in the system, what responses the system gives to inputs. Notice I'm not saying how. It's not doing the design at a system level. It's doing the what. Use cases also include the preconditions and the postconditions of the response. This tells you what we're expecting before and what system we're leaving, or what state we're leaving the system in. Another thing that's really important in use cases is what paths. You know, traditional text-based systems engineering, the systems engineers are very good at giving the primary path. What happens when everything goes right? But if you're a systems engineer and you're like me, you want to concentrate on what you're doing. You don't want the interruptions from the software guys coming over and saying, hey, what about this exception condition? What about that other exception condition? What use cases do, and the refinement of use cases do, is it forces the system engineer to go through all of those conditions when non-normal cases occur, so that they can start building out those exception conditions. In real systems, Those exception conditions make up the bulk of the work. So if we can get them specified up front, it improves our communication downstream, and we know what to expect. As I said before, there are several different ways to refine use cases. It can be in text. Coburn did all kinds of work on that and did a very good description of how to do step-by-step text-based use cases. Of course, I'm coming from a visual world. I'm a visual learner like most of you are, and therefore I prefer to see diagrams. Activity diagrams are one of the more common ways to refine it, and in the next section, next video, we'll talk about refining use cases with activity diagrams. Each path through an activity diagram gives a sequence, and that sequence diagram, that collection of sequence diagrams, are really good when you are that downstream receiver to only look at one condition at a time. It helps scope your work and assign that work to the different sprints that you're performing. Every system I've ever worked has states and modes, and therefore state charts are the ideal way to define those states and modes. It's much easier to define the states that one goes into in a state chart than to try to force it to work in an activity diagram, because the basic flow of a state chart is I'm in a state until something very specific happens, then I go to another state. Just like in real system, I'm unpowered until I receive power, then I go into power up until I'm finished setting everything up, and then I can go into operational. Very clear states. Okay, outside the system are the actors. Now, actors represent things that are outside the system. They're things that in general we're not going to model, but they are important because they're the users. There's the hardware that we're interacting with. They're things that we need to be concerned with when we're developing. Actors can represent a person, but they're more common in the embedded and safety critical world that they represent hardware or another system or an API. They're traditionally shown as stick figures, which is fine when you're dealing with other systems engineers or other software people, but sometimes it's confusing to people who are not either technically based or not familiar with the domain. Fortunately, most of the tools will allow you to replace the use case, the actor with an image that represents that actor. So in this case, I've got the gateway, and I showed it initially as a stick figure. Over here, I replaced that with a JPEG image of what the actor looks like. For anything that you're going to be putting out to higher level people, definitely do this. Okay, this is great. This defines the actors. But how do we start identifying actors? Well, one way is to look at the roles that the actor is going to be performing. And it's very common for a system user or a system attribute to be played by multiple roles. Let me give an example of that. A user who does some normal task might also be the administrator. In other words, he wears multiple hats. So what we want to do is show actors that are based on the context. I would have an actor for the user. Well, we'll get to that naming in just a minute. But I would definitely have another actor for the administrator to play the administrative roles. Now, this is one example of showing that logical versus physical role or logical versus functional role. We see this a lot. And it's a fine line. It's a balancing between having too many actors and not enough. But in general, look for the context. So how are we going to identify and how are we going to name actors? One of the fastest things that I do to go through is I draw a big circle around the system and I go through who or what uses the system. What information are they going to need or provide to the system? Who's providing that information? Is it coming from an API or is it being sent in? Where in the company is this piece of the system used? Is this something that's an upfront part Or is this something the pilot cares about versus something a ground maintainer cares about? Or is this something someone sitting in an office cares about versus the person working on the assembly line floor? That's a really good way to identify different roles and different ways of looking at actors. Naming an actor is very important. So that name needs to identify the role clearly. One of the things that is really common, and we really shouldn't do, is giving a name like user. If I'm looking at a smart home system, user doesn't really tell me much, whereas homeowner might, because homeowner would be different from maid. They're both users, but they use it in different ways. So be looking at that context, be looking at the role, be looking at what people are doing or what systems are doing within the system itself. Use cases have a bunch of different type of relations. I've put it all on this one slide so that you can think of it in context. So the first one is between actors and use cases. This relation here. This is just this shows communication. In the old days, we used to show arrowheads. We've stopped doing that for a couple of different reasons. But the main one is that it used to try to show the direction of interaction. And that got confused with who was calling and whatnot. So we've gone away and we just show the association here. It's non-directional so that it can, the action itself and the response can go either way. We also have relations between actors and other actors. In this case, we have a generalization, which is shown as an arrow with this closed arrowhead that is not filled in. What that shows is that in this case, the special access worker does most of the things that a system user does, but it also has some special roles. In the software realm, you can think of this as inheritance. Now, within use cases themselves, there's a couple of different relationships that we need to look at. The most common are the extends and the include. Include means that we're going to allow some common functionality to be pulled out and then included by other use cases. So in this case, I'm using the energy setback in my overall system that's used with the lights, and it's used with the HVAC, and it's used with humidity controls. I've got all of them together pulled out and used by each of those systems. Extend takes a specific point in the use case and adds additional information or additional usage to it. So here, in the base use case, we're just controlling the HVAC. Think of that as like a standard thermostat. But if we also want to monitor the humidity, well, that extends the control to when we turn it on and turn it off, not based just on temperature, but a combination of temperature and humidity. There used to be big fights about whether to use extend or include, and I had this on my team several times, and then I found a write-up that said, you know, it really doesn't matter which one you use, pick one and move on, because either way, you're going to have to do both of them. So in general, what I try to do is if I am going to reuse the same feature over and over again, that's include. If I'm only going to use it once, it's almost always extend. The third kind of relationship is this generalization relationship. So I can have a general relationship that says, in this case, control the door locks, but I can have a special case, a special access mode that only lets certain people in with certain codes at certain times of day. So that's it for use cases. Join us next time when we start about refining the use case, and we're going to start with activity diagrams and sequence diagrams. If you've got any questions, please visit our website. There you'll find a bunch of different artifacts. All of our videos are there. We've got some other podcasts and other papers that are available for you there. If you've got questions, please reach out. call 321-GANG, or if you need us for software sales or for some tool support, let us know. Thanks a lot.